Hi, I'm Matt Marshall. I'm founder and editor-in-chief of VentureBeat. We're here live from GTC 2024, talking with Ian Buck, Vice President and General Manager of Hyperscale and HPC at Nvidia. Welcome, Ian.
Hi, Matt.
So, Ian, you've just announced, or your CEO announced a couple of days ago, the newest generation of GPUs, the system called Blackwell. Can you talk a little bit about why it's such a big deal?
Yeah, every 2 years, Nvidia launches a new GPU platform.
Yeah.
This year it's Blackwell. It's the biggest GPU we've ever launched, 208 billion transistors, actually made up of two radically limited dies glued together to build one giant GPU. On top of it, that GPU is incredibly fast. It has over 20 petaflops of AI. That's compared to Hopper, the generation before, which maxed out at about 4. 20 petaflops is a lot. Our first big supercomputer was the Titan supercomputer at Oak Ridge National Labs with our Kepler GPU back in 2012. That entire supercomputer, about the size of a tennis court, was 20 petaflops.
Yeah.
I can now fit 20 petaflops in the palm of my hand.
Yeah. Ian, I mean, these are just massive computing technologies. There's a conversation in the industry right now about the move to deployment of generative AI, right? The notion is we're still in experimentation mode, but even then there's demand. Can you talk a little bit about who's actually going to use Blackwell, like in the here and now? I know it's coming out later this year, and then what are they using it for?
Yeah, last year we started to see the emergence of not just generative AI in terms of chatbots and interacting in text, but multimedia, multimodal generative AI, where we can type what a picture we'd like to see and it comes back as a full, beautiful drawing.
Yeah.
Or describe a scene, or even do in the research space, 3D video and animations. Now we're seeing like scientific applications being deployed. Not just the language of humans, but generative AI that can generate some proteins or possible drug candidates for curing different diseases. One of the challenges though with generative AI is that as the models are getting more intelligent and they can do all of these different amazing things, they're getting larger, bigger, and more capable. Today the state-of-the-art models are 1 trillion parameters. These models are huge. They don't fit on a single GPU, and you need lots of them even to have them interact real time. One of the goals of Blackwell is to take this 1 trillion parameter AI and democratize it. Allow everyone to be able to get the benefit of these giant models and what they can do for the way we interact with computers as regular users, but also industries, businesses, and scientists to be able to use 1 trillion parameter AI for their work or to improve the outcome of their business, their economies, or even their nations.
Yeah.
Blackwell is going to make it way easier and cost much less to deploy these giant models, and we're super excited to bring it to market.
Yeah, Ian, clearly Nvidia is benefiting from this. I mean, the market cap of the company has just exploded. I mean, you're third largest market cap company on the planet, I believe now. It just passed Amazon and Google. Are you worried? I mean, you're the product guy, so maybe this is a little unfair, right, in terms of your zone of responsibility, but are you worried about the industry getting a little ahead of its skis, in front of its skis here in terms of the actual deployment and usage of this, right? You're going off and building these massive systems. Jensen was there saying, hey, we still don't have enough, so maybe we're okay, but just coming from your perspective?
It's hard to describe or even track an exponential, and that's what AI has been.
Yeah.
The growth has been exponential,
yeah.
But it's not without good reason.
Yeah.
The opportunity for AI, which is basically software writing software, you're changing what data centers do. They're not just retrieving information and bringing it back to you, or allowing you to connect with, search for products and purchase things. Now we're turning them into AI factories.
Yeah.
They're token generators. And those tokens generate information that we can interact with and monetize, either by increasing our productivity in terms of co-pilots, or being able to ask questions of our data to optimize some of the business questions we have every day. So if you look at the economics, the tokenomics of data centers now, it's remarkable and dramatic. And that's really why there's so much pull for AI.
Right.
Now, as this business grows and these applications are going to grow, it's tough to predict where it'll all end up. One of the most hardest part of my job is to forecast for all the demand out there, but we can clearly see that the generative AI is game-changing in terms of how we deploy our technologies, use it, and changing all these business practices.
Yeah.
So overall, our job is just to continue to bring down the cost of deploying these models, allowing them to scale further, and at the same time provide an innovation platform so that the AI geniuses of the world that are coming up with the next GPT or next trillion parameter model can have a platform that's capable of doing so.
Yeah, Ian, something I wanted to ask is, how far up the software stack will Nvidia go? I mean, you're significant here because back in 2004, I think you started this software creep. You were instrumental to developing CUDA, right? Which was kind of a software and hardware combination, but the software being, as I understood it, breaking down tasks into ways to parallel process efficiently into chunks, and now speeding up to 2024, 20 years later, you're creating these NIMs, which is essentially microservices, packaging up these AI deployments, right? So all the way up the stack. How far is Nvidia going to go up the stack?
It's a great question, and we get asked this all the time.
Yeah.
We started obviously with a way of how to program this new kind of processor, GPU, that was originally designed for video games, computer graphics. Figuring out the color of every pixel on a monitor 1 million times over in a 30th of a second and throw it all away and do it again. That's what CUDA enabled. Make it easy for developers to write applications on GPUs. Since then, and fast forward 20 years later, CUDA is not just a way of programming a GPU, but it's an entire ecosystem of libraries and SDKs to let developers do their best work. It's now over 450 libraries and SDKs across not just what Nvidia develops, but the entire ecosystem is providing on our platform. In addition, we choose where we can accelerate further, to go up the stack, if you will, and make available domain-specific or vertical-specific platforms in the areas of healthcare or EDA or CAD software to help activate those ecosystems, those ISVs, to take the final step to connect with their customers and add value on top of our platform. Meanwhile, the strategy is always to keep that whole stack open. If someone wants to meet us, program all the way down to the GPU level, they can.
Yeah.
Consume all those math libraries that we've developed, they can. Interact with our vertical domain libraries, they're accessible to help activate and spur this market of accelerated computing. You mentioned NIMs, very important.
Yep.
You go to a website like Hugging Face, you'll see thousands of AI models, and there's more being added every day.
Yeah.
What NIMs really enable is to build the software microservices, the little building blocks, so that ISVs or cloud applications can easily integrate those models into an enterprise application and know that they're getting the best performance because NVIDIA's optimized those models. They've gone through full security checks, and they're tuned and designed to run amazingly well on NVIDIA in the cloud so that they can integrate it into their cloud application. Basically making AI as a microservice in every enterprise application.
You talked about security.
Yeah.
Right, and that's another component here. So Blackwell has a security component. I mean, I think you're wrapping security around these products as you move up the stack. Can you talk a little bit about how Blackwell protects AI models and AI deployments?
AI models are extremely valuable.
Yeah.
They basically are trained on all of your company's data,
yeah,
and encapsulated into one model. They represent the IP of your entire company sometimes. And that's why it's important to protect them, to make sure that they're secure. Even if you're running it on a third party's cloud or a hyperscale or data center, you want to know that your AI model is trusted and secure and is available for you and used in your application, but it's not going to leak. Blackwell actually supports secure AI. Every link between the CPU and the GPU, now over NVLink, is entirely encrypted and actually supports a trusted execution environment. We added this to Blackwell because the growth of these AI models are happening everywhere, and they're incredibly valuable and incredibly important to take to market.
Yeah, Ian, so let's talk a little bit about the networking. Now this is going back down the stack, as it were, or at least conceived as down the stack. Why is networking so important for AI applications, which are running on top?
AI just doesn't run on one GPU anymore.
Yeah.
Actually, for quite some time, when you either train a model or when you're doing inference or deploying a model, you actually need to collect multiple GPUs together to run these trillion parameter models. Even 100 billion parameter models need multiple GPUs working together.
Yeah.
Back actually in 2016, we started this journey of NVLink. The ability to take multiple GPUs and directly connect them to each other inside of a system so that they can work as one giant GPU. That was critically important both for training and inference in AI. With Blackwell, we've taken the next step up. For trillion parameter AI, particularly the mixture of expert models you've heard of with Google Gemini or Meta's No Language Left Behind, these models actually have lots of smaller AIs, all working together, all communicating. So we've increased NVLink to go now from inside of a single server, but actually at rack scale. Now we have a rack scale giant GPU, but we can't stop there. Certainly for training, we need to be building data centers to train these giant models. There we have to connect all those GPUs with every other GPU in the data center so we can train these models at scale, literally over trillions of sample data points. So at GTC we announced the next generation of InfiniBand, the Connect X8 and the Quantum X800, and also the Ethernet equivalents, the Spectrum X800. So whether it be InfiniBand or Ethernet, people can build AI data centers at scale and have the fabric for the entire data center and now the fabric within the rack, NVLink, to be able to train and deploy these giant models.
Ian, that's an incredible story. We could keep talking, but you're the product guy, and you have congratulations in terms of bringing it to today. I hope you get some vacation pretty soon. Is that coming?
Looking forward to it, yeah.
Okay, congratulations. We're looking forward to following your story in the coming years.
Thank you.
Guests, thanks for watching, and be sure to explore more sessions in the GTC catalog.